Hello and welcome. In this video, I'm going to walk you through the completed version of the e-commerce project we'll be developing throughout this training series. This demo will help you clearly understand the final outcome and how all the features work together within the application. Let's begin by running the project without logging in. As you can see, the first screen that welcomes us is the main product listing page for the customer side. Here, users can browse through all available products. Let's click the Details button on one of the products. We're taken to the product detail page, where we can see information such as the product name, category, barcode, description, price, and a field to select the quantity. This page is accessible even without logging in. Now let's try to add this product to the cart without being logged in. When we click Add to Cart, the system automatically redirects us to the login page because cart actions require an authenticated user. This demonstrates that our project already includes user-specific access control, even at this early stage. Let's now log in using a customer account. After logging in, we are redirected back to the home page. Let's find the same product again. Go to its detail page, select a quantity, and click Add to Cart. This time, because we logged in, the product is successfully added to the cart, and the system redirects us to the home page. Now let's go to the cart page by clicking on the Cart link in the navigation menu. On this page, we can see each product in our cart, along with its image, name, category, price, quantity, and total amount per item. We also see the cart summary on the side, showing the overall total for all items. What's great here is that users can increase or decrease product quantities directly from the cart page, and the totals are updated in real time. If we reduce the quantity to 0, the product is automatically removed from the cart. Next, we'll proceed to place an order. Clicking the Order button takes us to the order confirmation page, where we see a form pre-filled with our name, phone, address, and postal code. These can be updated if needed, for example, to send the order as a gift or to a different location. Below the form, there's a summary of the products included in the order. When we click Order Confirmation, our order is successfully created. Now let's track our order. We click the Orders link in the menu, and we are taken to a page listing all our past orders, including the total price and status. If the order hasn't been processed yet, there's an option to cancel it. Let's now look at the security aspect of our application. I will log out and then try to manually access the admin panel by entering the admin area URL. As expected, since we are not logged in, the system redirects us to the login page. This time, let's log in with a customer account and try accessing the admin panel again. Now, we are redirected to a Custom Access Denied page. This page informs the user that they do not have permission to access the requested resource. This feature ensures that only authorized users can access sensitive admin areas. Now let's log in with an admin account. After logging in, I'll enter the admin URL directly. This time, we are successfully taken to the admin dashboard. Here, you can clearly see that the layout and design are different from the customer side. The admin panel includes navigation links and tools tailored for administrative tasks, such as managing products, categories, and orders. With this structure, the application offers a clear separation of user roles, secure access control, and a user-friendly interface for both customers and administrators. To summarize, in this project, we build a complete and secure e-commerce system that includes role-based access, product browsing, cart and order management, and custom navigation tailored to user roles. If what you've seen here has caught your interest and you'd like to build this project step by step, I hope to see you in the course lessons. Hello. In this video, we will begin our project together. To do this, we will start by selecting Create New Project. I click on the Create a New Project button. Then, in the window that appears, I want to create a blank project, so I navigate to Blank Solution. I type Blank Solution. After selecting Blank Solution, I proceed by clicking Next. Here, I need to give my project a name. I name it e-commerce. I click the Create button to create my project. After clicking the Create button, my project is now created. Now, for the onion pattern, we need at least 4 layers. To create these 4 layers, let's first create our web layer. After adding this web layer, we will run our project to ensure it functions correctly before proceeding with other steps. Now, let's discuss how to add this web layer. I right-click on the solution. From the menu that appears, I select Add, and then I click on New Project. After selecting New Project, I need my web layer to follow the MVC architecture. To find it, I type MVC and some options will appear. Let's confirm. After typing MVC, you can see that several options appear below. The project we will work with is ASP.NET Cool Web App Model View Controller. One of the key points to pay attention to is ensuring that our selected language is C#. Why am I mentioning this? When we type MVC, different platform options may appear. Even if Web App or Cool Web App appears, their languages may differ. So, there are 2 important things to check. Title: ASP.NET Cool Web App Model View Controller. Supported language: C#. After confirming that it is C#, I select this option. I click Next to proceed. Now, I will name my project. To maintain readability and organization in my project, I always start with the solution name. In this case, I will name it e-commerce. After typing e-commerce, I add a dot and specify the layer name. Since this is the web layer, I name it e-commerce web and proceed by clicking Next. Now, which .NET framework will we use? Of course, we will select the latest .NET 9 framework. After selecting the .NET 9 framework, I choose authentication type as individual accounts so that we can implement identity operations. I do not make any other changes to the settings and click the Create button at the bottom right to proceed. After clicking Create, my project is added shortly after. Once the project is added, without making any modifications, I immediately run it to verify that the web layer is correctly set up. When you first create the project, a symbol may appear on dependencies. You should wait for this symbol to disappear because it indicates that some packages and frameworks in dependencies are still being installed. Once the symbol disappears, I can now run my web project. Let's run it and verify. As you can see, the page has loaded and our MVC project is successfully running. After confirming this, we can proceed step by step in our upcoming videos. See you in the next lesson. Take care. Hello. In this training series, we'll be building a fully functional and scalable e-commerce web application from scratch, step by step, using ASP.NET Core MVC. This is not just a coding exercise, it's a real-world software development journey. We'll start by designing a layered architecture and applying professional software engineering principles, including onion architecture, to ensure the project is clean, maintainable, and scalable. So, what will this project teach us? You'll learn how to build a complete multi-layered solution from the ground up. We'll implement ASP.NET Core Identity for secure user authentication, registration, and role management. You'll set up role-based access control to ensure only authorized users can access specific areas of the application. By using areas, we'll clearly separate the admin panel and customer panel for better structure and usability. We'll create dynamic views using tag helpers and explore Razor syntax in detail. With Entity Framework Core, we'll handle all data operations using code-first principles and repository patterns. You'll develop fully functional modules for shopping cart management, order processing, role seeding, and secure navigation. To improve the user experience, we'll also work on menu configuration, navigation updates, and user-friendly error pages like access denied. Along the way, we'll identify and resolve common bugs, ensuring you gain valuable problem-solving skills applicable in real-life scenarios. More than just building a project, this course will help you think like a software developer and understand how to approach full-stack web application development professionally. By the end of this series, you won't just have a portfolio-ready e-commerce application, you'll be one major step closer to becoming a confident and capable .NET developer. Let's get started on this exciting journey together. Hello. In this video, we will begin our project together. To do this, we will start by selecting Create New Project. I click on the Create a New Project button. Then, in the window that appears, I want to create a blank project, so I navigate to Blank Solution. I type Blank Solution. After selecting Blank Solution, I proceed by clicking Next. Here, I need to give my project a name. I name it e-commerce. I click the Create button to create my project. After clicking the Create button, my project is now created. Now, for the onion pattern, we need at least 4 layers. To create these 4 layers, let's first create our web layer. After adding this web layer, we will run our project to ensure it functions correctly before proceeding with other steps. Now, let's discuss how to add this web layer. I right-click on the solution. From the menu that appears, I select Add, and then I click on New Project. After selecting New Project, I need my web layer to follow the MVC architecture. To find it, I type MVC and some options will appear. Let's confirm. After typing MVC, you can see that several options appear below. The project we will work with is ASP.NET Core Web App Model View Controller. One of the key points to pay attention to is ensuring that our selected language is C#. Why am I mentioning this? When we type MVC, different platform options may appear. Even if Web App or Core Web App appears, their languages may differ. So, there are 2 important things to check. Title: ASP.NET Core Web App Model View Controller. Supported language: C#. After confirming that it is C#, I select this option. I click Next to proceed. Now, I will name my project. To maintain readability and organization in my project, I always start with the solution name. In this case, I will name it e-commerce. After typing e-commerce, I add a dot and specify the layer name. Since this is the web layer, I name it e-commerce web and proceed by clicking next. Now, which .NET framework will we use? Of course, we will select the latest .NET 9 framework. After selecting the .NET 9 framework, I choose authentication type as individual accounts so that we can implement identity operations. I do not make any other changes to the settings and click the Create button at the bottom right to proceed. After clicking Create, my project is added shortly after. Once the project is added, without making any modifications, I immediately run it to verify that the web layer is correctly set up. When you first create the project, a symbol may appear on dependencies. You should wait for this symbol to disappear because it indicates that some packages and frameworks in dependencies are still being installed. Once the symbol disappears, I can now run my web project. Let's run it and verify. As you can see, the page has loaded and our MVC project is successfully running. After confirming this, we can proceed step by step in our upcoming videos. See you in the next lesson. Take care. Hello. In this video, we will create the remaining layers needed for onion pattern together. Now, to create our first layer, I right-click on the solution, select Add, and then Confirm New Project. After selecting New Project, the layers we will add here must be class library. Since I have recently used class library, it appears in my recent projects, but in case you haven't used it before, I will show you how to find it in the search section. Now, we type class library in the search box above, and among the class library options that appear, just like when selecting our web project, there are some important things to pay attention to. When I type class library, as you can see, many different options appear. Since we will be using .NET Core and not .NET Framework, we should select the first option that appears, class library, .NET Core but .NET Standard. After ensuring that the programming language is C#, I select this option and click Next to proceed. Then, as you remember, what do I do first? First, I enter the name I gave to my solution. After writing e-commerce dot, I specify the name of the layer. Since I want to create the domain layer now, I add domain to e-commerce. After setting this name, I click Next to continue. To ensure that our entire project works in harmony, we also select the .NET 9.0 framework for this class library project and then click Create to complete the creation process. As you can see, our e-commerce domain layer has been created. A class 1.cs file is automatically generated here. We can delete this default class file. First, let's establish the main structures of our core layers. We will go into details in the next video. Now, let's move on. What other layers do we need? The missing layers are application and infrastructure. Let's first add the application layer. Again, I go to Solution, right-click, select Add, and Confirm New Project. Since we already selected class library while adding the domain layer, you no longer need to search again. Instead, you can directly select Class Library from the Recent Project Templates section on the left and click Next. After clicking Next, we proceed as usual. We enter our solution name, write e-commerce dot, and then name this layer application. Again, I click Next, select .NET 9.0 Framework, and then click Create to proceed. Here as well, we can delete the default class 1.cs file. Finally, we need to create the infrastructure layer. Again, I go to Solution, right-click, select Add, and choose New Project. Then, I confirm Class Library. Click Next, and enter the name e-commerce infrastructure. After setting this name, I click Next. Select .NET 9.0 Framework, and then click Create to finalize the process. Lastly, I delete the default class 1.cs file here as well. Thus, we have successfully created our core layers. In the next video, we will continue with the remaining steps. Hello! In this video, I will explain how to install the necessary packages for our layers. I will explain the installation process for each layer in separate videos because, while installing the packages, I will also provide summary information about what they do. Rather than just adding these packages blindly, we will at least understand what each package is used for. Now, let's start with the e-commerce web layer and install our packages. There are already some pre-installed packages. First, let's briefly summarize these packages. These packages come pre-installed by default in our project. The Entity Framework core package includes tools for debugging and diagnosing errors in Entity Framework core. It also helps us better understand database-related errors. We need to use this package to catch migration errors and understand error messages. It also allows us to analyze database errors more effectively during development. The Entity Framework Core Identity package is part of ASP.NET Core Identity, which is the user management system. It allows us to manage authentication and authorization processes. We use this package when we want users to register, log in, or reset their passwords, and when we need role-based authorization. The Identity UI package provides ready-made UI components for Core Identity. It includes pre-built pages for login, registration, and password reset. In this video series, we will also show how to customize these pages. If we don't want to write UI code for identity operations from scratch, we need this package. For example, if we don't want to manually create login and registration pages and want to save development time, this package is beneficial. Its advantage is that it speeds up the development process so that we can focus on our main project. Since Microsoft has already provided a ready-made infrastructure for managing identity operations, we prefer to use it. The Entity Framework Core SQL Server package enables Entity Framework Core to work with SQL Server. It is needed to create migrations and execute queries in SQL Server. The Entity Framework Core Tools package allows us to use .NET F commands for Entity Framework Core. It makes migration creation and management easier. We use this package to run CLI commands like .NET F migrations add and .NET F database update. It helps us automatically manage database operations. Now, Let's talk about the packages we need but are not pre-installed. We can start by installing Entity Framework Core Relational. To do this, right-click on the e-commerce web layer, select Manage NuGet Packages from the menu. Go to the Browse section and type Microsoft.Entity Framework Core Relational in the search box. Select the first result carefully. Click Install and choose the latest version, which is currently 9.0.1. Click Accept and the installation process will begin. To ensure consistency and avoid errors in your project, you can install the same versions I am using. To check if the installation was successful, look for the Uninstall button. If it is enabled, it means the package was installed successfully. We can also verify the installation from the Installed Packages section. Next, we install Identity Stores. In the search box, type Microsoft, extensions, Identity, Stores. Select the latest version, which is 9.0.1, and click Install. Click Accept and wait for the installation to complete. Once installed, a green checkmark and Uninstall button will appear, indicating that the installation was successful. We then install Code Generation Core by searching for Microsoft.Visual Studio Web.CodeGeneration Core. We select the latest version, which is 9.0.0, click Install, and click Accept. Similarly, we search for and install Microsoft.Visual Studio Web.CodeGeneration Design, clicking Accept when prompted. After completing the installations, let's check if we have all the necessary packages. The installed packages include Entity Framework Core Diagnostics, Entity Framework Core Identity, Entity Framework Core Identity UI, Entity Framework Core Relational, Entity Framework Core SQL Server, Entity Framework Core Tools, Identity Stores, Code Generation Core, and Code Generation Design. If any packages are missing, Visual Studio will notify us while coding, and we can install them when needed. Since we provided detailed explanations, this video took a bit longer. Now, let's summarize the packages we installed. Code Generation Design is used for code generation and scaffolding processes. Code Generation Core manages automatic code generation for scaffolding, such as generating Identity UI pages automatically. Identity Stores expands the ASP.NET Core Identity Store functionality, allowing us to use Identity with SQL Server. Entity Framework Core Relational enables Entity Framework Core to work with relational databases like SQL Server. Now that we have explained these parts, in our next lesson, we will continue with the application layer. Hello everyone. In the previous video, we completed the process of installing the necessary packages in the web layer. In this video, we will proceed with installing the required packages for the application layer. Before we start, it would be beneficial to update the default packages that were installed when we created the web layer. This is because when we install packages in the application and domain layers, the latest versions will be fetched. If you look closely, some packages still appear as 9.0.0, while the latest versions are actually 9.0.1. Of course, some packages may not have a 9.0.1 update and might remain at 9.0.0. To check for updates, I go to the e-commerce web layer, right-click and select Manage NuGet Packages. Once inside, I see the Browse, Installed and Updates sections. I navigate to the Updates tab to check for available updates. After refreshing the Updates section, I see that 5 packages have updates available. These include Entity Framework Core, Diagnostics, Identity, Identity UI, SQL Server and Tools packages. I select all of them, click Update and wait for the updates to be installed. I click the Accept button on the confirmation screen to proceed with the updates. After completing these updates, we can now proceed with installing the necessary packages in the application layer. Since the application layer is a class library, it does not contain any pre-installed packages by default. Now, we will start installing the required packages inside this class library. I navigate to the application layer, right-click and select Manage NuGet Packages. Then, I go to the Browse section to start searching for the required packages. I won't go into too much detail in this section because most of the important packages were already installed in the web layer. Also, since some packages are the same as those in the web layer, there's no need for repetition. To keep the video short, we will proceed quickly. First, let's search for the first package we need, Microsoft.Arth Core, Hosting. I search for Microsoft.Arth Core, Hosting in the Package Manager. As you can see, I found the package. I select it and click Install. The latest version available is 2.3.0. After selecting it, I click Accept on the confirmation screen and the installation begins. Once this is completed, the next package to install is Microsoft.Entity Framework Core, Tools. I carefully select this package because there might be other similar looking packages. Usually, the package we need appears at the top, but it's always good to double check. The latest version is 9.0.1, so I click Install. Once again, I confirm the installation by clicking the Accept button. After confirming, I see that the installation is completed. Now, I search for Microsoft, Extensions, Identity, Stores. I click Install, then confirm the installation by clicking Accept and wait for the process to finish. Finally, I search for Microsoft.Arth Core, MVC.View Features. The latest version available is 2.3.0. I click Install and confirm with Accept to complete the installation. Now, let's quickly go over the explanations of the packages we installed. To avoid repetition, we won't go into details about identity stores and tools since we already covered them in the web layer. One new package here is Microsoft.Arth Core, Hosting. The Microsoft.Arth Core hosting package is responsible for managing the execution of ASP.NET Core applications. It provides functionalities for configuring middleware, managing the application lifecycle, and initializing web servers. Why do we need this package here? Just like in the web layer, we will need to configure some middleware components in the application layer. Specifically, since we will be handling user authentication and authorization in the service layer, we need this package. Now, why did we install Microsoft.AskNetCore MVC.ViewFeatures? This package provides view features for ASP.NET Core MVC and Razor pages. It enables the use of view data, temp data, and other features. Additionally, it is used for HTML rendering, layout management, and dynamic data transitions. The reason we installed it here is that some views will be used within the application layer, and we need this package to support them. Alright, that concludes this video. In the next video, we will continue with installing the necessary packages in the domain layer. Hello. In this video, we will install the required packages for the domain layer. Since the packages we will install in the domain layer have already been explained in previous videos, we can proceed directly with the installation without repeating the explanations. To install the packages, I navigate to the e-commerce.domain layer. Right-click and select Manage NuGet Packages. I will close any other open windows to avoid confusion. In the window that appears, I go to the Browse tab. Let's search for the first package we need. I search for Microsoft AskNet Core MVC Core. After verifying the details, I see that the latest version is 2.3.0. I click the Install button. Then, on the confirmation screen, I click Accept to approve the installation. To install the next package, I perform another search. I search for Microsoft Entity Framework Core.Tools. Again, after verifying the details, I click the Install button. On the confirmation screen, I click Accept to complete the installation of this package. Next, we need the Microsoft Extensions Identity Stores package. I quickly perform a search for it. For the Identity Stores package, I follow the same steps to complete the installation. The installation is now complete, and finally, I need to install the Microsoft Visual Studio Web Code Generation Design package. I start the installation by clicking the Install button and confirm the installation by clicking Accept on the confirmation screen. With this, we have completed the package installations for the domain layer. In the next video, we will proceed with installing the required packages for the infrastructure layer. Hello. In this video, we will proceed with installing the necessary packages for the infrastructure layer, which is our final layer. Let's quickly start the process. The infrastructure layer, like the web layer, requires a significant number of package installations. For this, I navigate to the e-commerce infrastructure layer, right-click and select Manage NuGet Packages. Then, I go to the Browse tab and quickly start installing the required packages. First, I search for Microsoft.Entity Framework Core Tools. Since we are now familiar with these processes, I quickly verify it and click Install. As we have performed these steps multiple times in previous layers, I assume you are already familiar with the process. So, I will proceed a bit faster. The next package is Microsoft Extensions Identity Store. Only one option appears, so I clicked Install and then Accept to confirm the installation. I wait for the installation to complete, but I also want to see the Uninstall button to verify that the package has been successfully installed. Now, this package is installed. The next package is Microsoft .ARSNet Core, MVC Core. We install this quickly as well. The next package is Microsoft .Visual Studio Web. Code Generation Design. The latest version appears to be 9.0.0. On the confirmation screen, I clicked Accept to proceed with the installation. The next package is Microsoft .ARSNet Core Identity.EntityFramework Core. The latest version available is 9.0.1. I proceed with the installation and confirm it by clicking Accept on the confirmation screen. Let's not forget Microsoft .Visual Studio Web. Code Generation Core. We must install this as well. I click Install and check the installed packages. I realized that we haven't installed the SQL Server package. Let's quickly install that as well. I search for Microsoft .EntityFramework Core .SQL Server. This is one of the essential packages that we must install. Now that this package is installed, I see the green check mark confirming its successful installation. At this point, the package installations are complete. In the next video, we will begin distributing responsibilities within the web layer. What do we mean by distributing responsibilities? For example, we will determine where models will be located, where data will be stored, etc. We will properly structure the components across different layers. Additionally, we will add the necessary references and gradually start organizing our project. In our next video, we will begin assigning project references and continue from there. That's all for now. See you in the next lesson. Hello. In this video, we will carry out the process of adding project references together. Let's proceed step by step. Let's add the references required for the application layer. To add a reference to the application layer, I right-click on the project. I go to the Add option and select Project Reference from there. After selecting Project Reference, our application layer will only reference the domain layer. Since the domain layer contains structures, such as entities and interfaces, it will need access to them. Therefore, we need to add the domain layer as a reference to the application layer. No references are added to the domain layer. By default, project references are not added to the domain layer. Our next layer is the infrastructure layer. Here, I again right-click, select Add, and then choose Project Reference. For this layer, we also need to add the domain layer as a reference. Lastly, which layer remains? The web layer. In the web layer, I again right-click, select Add, and then choose Project Reference. Here, we add two layers as references. One is the infrastructure layer, and the other is the application layer. I click OK to confirm. As you can see, our references have been successfully added. After adding the references, in the next step, we will start organizing folder structures within the layers. We will arrange the file structures within these layers. After this organization, we will gradually begin creating our own files and structures. In the next video, our first step will be moving the existing structures. Now, I am concluding this video here. Hope to see you in the next video. Hello. In this video, we will carry out the process of moving some existing files and folders into the appropriate layers. To do this, the first folder structure we will move is the data folder. Where should we move the data folder? We need to move the data folder to the infrastructure layer. Now, I right-click on the data folder, select Cut, then navigate to the infrastructure layer, right-click and select Paste. The folder appears to have been moved here. However, there are a few things we need to adjust. First, I open the application DB context.cs file. If you notice, it contains the e-commerce web data namespace. We need to change this. What should we change it to? Our layer should now be e-commerce infrastructure. So, I modify the e-commerce web part accordingly. After making this change, let's also check the migrations folder. Here, when we hover over the red highlighted area with the using directive, we see an error. To fix this, we need to reference using e-commerce infrastructure data. Now, what can we do? We can remove the web data reference. Similarly, I go to the migrations folder where the migration files are located and update the references to infrastructure. After making these changes, I save the file. This completes the restructuring of the files inside the data folder. After completing these adjustments, we can close these files. Now, what's next? We have a models folder. We will no longer use this models folder. So what do we need to do? I navigate to the domain layer. In the domain layer, I will create a new folder. To do this, I right-click on e-commerce, domain. I select Add, then New Folder. I name this folder Entities and confirm. Now, I move the errorviewModel.cs file into the Entities folder. What can I do next? I can delete the Models folder in the web layer. To delete the Models folder, I right-click on it, select Delete, and confirm the deletion. After doing all this, are we finished? Let's check. I open the program.cs file. When I open program.cs, I notice errors related to application DB context. This happens because application DB context has been moved to a different directory. How do I fix this? I remove the e-commerce web reference. Then, I navigate to Application DB Context, press Ctrl+, dot, and from the pop-up window, I select Using e-commerce, Infrastructure, Data as a Reference. That's all it takes to fix the issue. Where else do we need adjustments? Inside the Views folder, there is a file named error.cshtml. When we open this file, we see ErrorViewModel at the top. There is no error here, but when we check ErrorViewModel.cs, we see that its namespace is e-commerce web models. What should we do? This file is no longer in the web layer. It is now in the domain layer, and it is no longer inside the models folder, but inside the entities folder. First, I correct the namespace inside the file. Then, I return to error.cshtml, where I can see that ErrorViewModel now appears correctly. Technically, we could write a long reference like e-commerce, application.viewModels.ErrorViewModel. However, this is not the best approach. To ensure that future entities are recognized automatically, we need to make an important adjustment. What is this adjustment? I locate and open the _viewImports.cshtml file. When I open it, I notice that the @usingModels directive throws an error. I need to correct this. Initially, I mistakenly moved ErrorViewModel to the Entities folder, assuming it was an entity. However, it is actually a view model. Let's fix this mistake. View models should be kept inside the application layer. To fix this, I right-click on the application layer, select Add, and choose New Folder. I name this folder View Models because this is not a Models folder. The confusion arose because we moved it from the Models folder. However, based on its name, ErrorViewModel is clearly a view model. I move ErrorViewModel.cs into the View Models folder and update the namespace accordingly. Now, the namespace should be e-commerce application.viewModels. After making this adjustment, I go back to program.cs to check if any further changes are needed. Everything seems fine. Now, I return to _viewImports.cshtml. I update the @usingApplication.viewModels directive. Finally, when I open error.cshtml, I can see that ErrorViewModel is now recognized correctly. When I hover over it, I confirm that it is referenced as e-commerce application.viewModels.ErrorViewModel. In this video, we have learned how to move existing files and folders into their respective layers. In the next step, there are still some adjustments we need to make inside the web layer. We will work on those together. For now, I am concluding this video. See you in the next one. Hello. In the previous video, we carried out the process of moving files into the appropriate layers. In this lesson, we will continue with the necessary checks and corrections as a continuation of those operations. Now, if you remember, in the previous video, I moved the ErrorViewModel file into the Entities folder. Since it corresponds to a model, I placed it there, but we mentioned that it should not be in this folder. Instead, it should be inside the View Models folder. The file is still here, so I right-click and select Delete, then confirm the deletion. This is the first step we need to complete. Apart from this, let's check what else needs to be corrected. To make this process easier, let's run our project first. As you can see, when we run it, we encounter some errors. By listing the errors below, we can identify and resolve them more efficiently. Now, let's go through them step by step. We see an error related to Create Entity Schema. Which file is causing this issue? Looking at the data folder under the infrastructure layer, within the migrations folder, we can see that the designer file, which starts with 00, contains an error. So, what is the cause of this error? Here, we performed the e-commerce, infrastructure, data, migrations operation, but since we did not update this in the designer file, we are encountering this issue. First, let's fix this part. After that, we can remove the e-commerce, web, data layer. It seems like these errors have been resolved. Let's save the changes. Now, let's check the second error. It looks like this error has also been fixed, as it was related to the previously corrected layer. The error message states that there is no e-commerce, web, models layer. If you remember, we had removed the models namespace. Where is this error occurring? In Error View Model. First, let's remove this unnecessary reference. Then, I navigate to the Error View Model file, press Ctrl and Dot keys at the same time, and from the window that appears, I select using e-commerce. Application.View Models. If you remember, we had moved the Error View Model file into the View Models folder. This way, we have eliminated the errors. Now, let's check if our project runs properly. I run it again, and as you can see, our page loads correctly, and we can see that it is working without issues. Yes, we have completed these adjustments. After making these changes, we were also planning to make some modifications to the web layer. However, since combining both processes in a single video would make it too long, we will handle that separately in the next video. At this point, we have successfully fixed the issues related to the file movements and verified our corrections. See you in the next video. Hello. In this video, we will be making adjustments in the web layer. Let's start organizing the file and folder structures for the web layer. I navigate to the Areas section. In the Areas section, we will have a layer for admins and another one for customers. By default, there is also an identity folder. Now, after selecting areas, let's see how to add an area and how we create these structures. I right-click on Areas, go to Add, and select Area from the available options. After choosing Area, I select MVC Area and proceed by clicking the Add button. First, I want to add an admin layer. The admin layer is now being created using scaffolding. As you can see, code generation is running. Now, as you can see, we have created an admin area inside the Areas section. Here, we receive a readme.txt file generated by scaffolding. This file contains instructions on how to structure our route path. This will be useful later. For now, I will leave it open and even pin it. I will show you where we will use this root structure in the upcoming steps. Besides the admin area, what other area do we need? In addition to the admin area, we also need a customer area. To create it, I right-click on the Areas folder, select Add, and choose Area. Following the same steps, this time I name the area as Customer. Then, I click Add and wait for the scaffolding process to complete. As you can see, our customer and admin areas have been successfully created. Now, within the admin and customer areas, you will see that folders such as controllers, data, models, and views have been generated. If you remember, we had already moved the data and models folders. We no longer need these folders, so we can delete them. I right-click, select both folders, and click Delete to confirm the deletion. I perform the same operation for the customer area, deleting the data and models folders. Now, there are specific structures that need to be included in the areas folders. So, what are these? If you recall, our main root contains some important files. Under the Views folder, we have two files. One is _view imports.cshtml and the other is _view start.cshtml. I select and copy these two files. Then paste them into the Views folder inside the admin area. Shortly, I will also paste them into the customer area. Now, the first thing we need to do here is adjust the _view start.cshtml file, which contains the layout definition. What does the layout setting say? It directs the system to look for the layout.cshtml file in the current directory. However, this actually refers to the shared folder inside the Views directory. The problem is that our area does not have a shared folder or a shared layout file. I want to manage the layout from a single location, which is the Views have shared a layout.cshtml file in the main root. For this reason, simply writing _layout here is not enough. What do I need to do? I need to modify the _view start.cshtml file inside the Views folder under the admin area. I update it so that it references the layout.cshtml file inside the Views shared folder in the main directory. After making this change, our layout structure is properly considered. Next, let's check the _view imports.cshtml file. Do we need to make any changes to this file? Actually, the _view imports.cshtml file can remain the same as the one in the main directory. However, there is one more layer that we should add. I navigate to the file and add the following. At using e-commerce, domain, entities. However, since there is currently no file inside the Entities folder, this will result in an error. After creating the necessary files, we can activate this line. For now, I will comment it out. After completing this step, I copy the Views files inside the admin area and paste them into the Views folder in the customer area as well. This way, we have completed part of the required modifications inside the web layer. Now, in the next step, if you remember, we need to configure the route pattern. Let's discuss where we should define the route pattern and how to implement it in the next video. For now, I will end this video. See you in the next one. In the previous video, we made adjustments within the area section. In our previous video, we referred to views, but I noticed that I had written view instead. So, let's correct these areas. Similarly, in the _viewstart.cshtml file inside the customer section, I changed the view definition to views and saved my files. Now, we can begin the next steps. First, I will close all the open files to prevent any confusion. At this stage, if you remember, there was a pattern mentioned in the scaffolding README file. I had mentioned that I would show you how to apply it. Let's pin this file again, as we accidentally closed it. Then, when we open the program.cs file inside our web layer, we can see that there is a map controller route definition and a pattern. When we look at the scaffolding file again, it tells us that we need to modify the pattern. So, what do we see in our current pattern? By default, if no controller, action, or ID is provided, the default home controller and index action will be used. If we specify a controller and action, their values will override the defaults. However, if left empty, it will direct the page to the home controller and index action. So, what kind of modification do we need to make here? Our current pattern includes controller, action, and ID definitions. However, scaffolding suggests an improvement. In addition to controller, action, and ID, we also need to add an area definition. Now, let's proceed with adding the area definition. I copy the suggestion from the scaffolding file, which includes area, exists along with the symbol. Then, I navigate to the program.cs file and paste the definition there. However, there is a difference here. In the scaffolding file, :symbol is used, while we use an equal symbol. Now, I need to determine which area I want to set as the default. I define the admin area as the default. With this, we have now defined the route structure and its pattern. However, at this point, the admin area does not have a home controller or an index action. For now, in this video, we have only defined the route. In the next video, we will create our controllers and, for testing purposes, move the default home controller to the admin area to verify our setup. After that, we will check whether the defined pattern is working correctly. If our route functions properly, we will proceed to the next stages. For now, I am ending this video. See you in the next video. In this video, we will begin creating the entity files that will store our table structures. In other words, we will create our data entities. Which layer and folder should we place these entities in? If you recall, we previously had a models folder in the web layer. However, in accordance with the Onion architecture, we decided that our entities should reside in the entities folder within the domain layer. Our entities will be located in the domain layer, while our view models will be created in the application layer. This approach clarifies responsibilities among the layers and provides an organized structure. Now, before diving into the coding, let's determine which entities we need and create them one by one. To do this, I navigate to the domain layer. I right-click on the entities folder within the domain layer to add new classes. We will create all of our entities in this folder. First, I add the entity named Application User. Then, I return to the Entities folder and add an entity named Cart. Next, I add an entity called Category, which will store the category information for products. To allow for potential expansion of the project, I also add an entity named Company. After that, I create the product entity, which will hold the basic information about products. I add the product image entity to store the product images. Additionally, customers need to transform the products in their cart into an order, so we require an entity called Order Product. I create Order Product to store general order information. Finally, I create Order Details to manage the specific data of the products in an order. Thus completing the entity creation process. At this point, I would like to briefly explain the difference between Order Product and Order Details. Order Product contains the main details of the order, for instance, total cost, address, customer details, while Order Details specifies which products appear in the order. We will explore the relationship between these two entities more thoroughly in upcoming videos. Before moving on to the next video, I want to address an important point. We need to update the access modifiers for all of our entity classes. By default, they are set to internal. We need to change them to public. The internal modifier only permits access from within the same assembly, but we want these entities to be accessible from all layers. After changing each entity class from internal to public, we have completed the creation process. In subsequent videos, we will begin defining the necessary properties within each entity. I will end this video here to keep it concise. As I mentioned before, I divide the topics so that it is easier to follow the development of the project. See you in the next video. In this video, we will be implementing the code for our application user entity. First, we will write the code, and then I will provide explanations about what we have written. Initially, we make sure that our application user class inherits from the identity user class, and then we implement the code for the properties we need. After completing the coding process and defining our properties, let's discuss these codes in more detail. First of all, in this line, you can see that the application user class inherits from the identity user class. So what advantage did we gain by deriving application user from identity user? Most importantly, we can use the standard identity features present in Identity User. If you ask, what are the standard entity features in Identity User, you'll notice it already contains username, email, password, security stamp, and many other properties, which we inherit by deriving from Identity User. Why didn't we just use Identity User directly instead of creating a class like Application User and deriving from Identity User? Of course, we chose this approach because we wanted to add additional features specific to our application, for example, full name, address, postal code, cell phone. Hence, we created our own class. Here, we have two different attributes that appear to be underlined in red as if they are causing errors. We call these definitions attributes. Let's explain required first. This is a data annotation expression that belongs to the system.componentModel.dataAnnotations namespace. If you hover over required, then press Ctrl+. You will see which namespace it belongs to. This attribute defines that this field must be filled before being saved to the database or undergoing other validation processes. The user will receive a validation error if they leave this field empty. The second attribute is a not mapped, which is also a data annotation expression located in system.componentModel.dataAnnotations schema. When we apply this attribute to a property, Entity Framework, or a similar ORM tool understands that this property should not correspond to a column in the database, differentiating it from other properties. In other words, this field will not be stored in the database and is considered an external field. For example, we only want to store the role field in our code and do not wish to write it to the database, which is why we use this attribute. Looking at the other properties, we have full name defined as a string. Because we marked it with the required attribute, the user cannot leave this field empty and must enter a string. Address, postal code, and cell phone are also string types, but do not have the required attribute, meaning they can be left empty. As mentioned, the role property is marked with a not mapped, so it will not correspond to a column in the database. For instance, if we assume that our system obtains a user's role information from another model or an external source, this field can simply hold a temporary or short-term value without ever being written to the database. In our application, because we manage role information in a different table, we do not need to store this data in the application user table. Thus, we have now finished coding and explaining the application user entity. See you in the next video. In this video, we will examine the code for our cart entity and discuss the purpose of each line in detail. We have already written our code. Now let's go through each section and explain its functionality. Public cart count equals 1. This part defines a constructor for the cart class. Whenever a new cart object is created, the count property is automatically set to 1. This way, when initializing a cart, the quantity of the added product starts at 1 by default. Key, public and ID get set. Key is a data annotation attribute belonging to the system.componentModel.DataAnnotations namespace. It indicates that the ID property will serve as the primary key in the database. ID is of type integer, and it may be configured for auto-increment or similar behaviors, though these details can depend on the database provider and other settings. Public string app user ID get set. Public and product ID get set. These two properties store foreign key values used to link to other tables in the database. App user ID links to the user's identity, a record in the application user table. Product ID links to the product's identity, a record in the product table. Public int counter get set. Public double price get set. Count keeps track of how many items of this particular product are in the cart. In the constructor, it is set to a default value of 1. Price holds the current price information for the product in the cart, or the unit price of the added item. In this example, it is defined as a double. Depending on application requirements, you may choose decimal or another suitable type. Foreign key, app user ID, public application user app user get set. Foreign key, app user ID is another data annotation attribute belonging to system.componentModel.DataAnnotations schema. It tells Entity Framework, or a similar ORM, that this app user property represents a record in the application user table using the app user ID property as the foreign key. Consequently, the app user ID value in cart can be used to fetch the associated application user object. Foreign key, product ID, public product get set. Similarly, the foreign key, product ID attribute indicates that the product property references a record in the product table based on the product ID foreign key. This allows Entity Framework to establish a relationship between cart and the actual data in the product table. Through this entity, cart, you can track the product a user has added to their cart, the quantity, count, and the price of that product. The cart table is linked to both application user and product via foreign keys. A minor initialization in the constructor ensures that the default quantity for any newly created item in the cart is 1. With that, we've completed our line-by-line explanation of the cart entity. We hope this helps you better understand the purpose of each property and how the code functions. See you in the next video. In this video, we will examine the category entities code. After writing the code, we will explain each line so we can better understand how it is used in our project. Key, public and ID get set. This line indicates that the ID property will serve as the primary key in the database. Key is a data annotation attribute belonging to the system.componentModel.DataAnnotations namespace. It ensures that this property uniquely identifies each record in the table. For example, it may be an auto-incrementing integer. Required, public string name get set. The name property stores the name of the category. The required attribute is also a data annotation that prevents this property from being null or empty. In other words, when a category record is created, the name field must have a value, otherwise, a validation error will occur. That's all for our category entity. However, depending on the needs of the project, additional fields, for instance, description, created date, or parent category ID, can be added at a later stage. For now, this ensures that each category record has an ID serving as the primary key and a mandatory name. In summary, within key, we mark the ID property as the primary key. Using the required, we specify that the name field is mandatory and cannot be left blank. Hence, when Entity Framework creates the category table, the ID column is designated as the primary key and the name column does not accept null or empty values. This helps maintain data integrity and correctness through built-in validation rules. With that, we have completed our explanation of the category entity. In the next video or step, if more advanced features or relationships are needed, we will explore how to incorporate them. For now, this is sufficient. Take care and good luck with your project. In this video, we will examine the coding for the order details entity. After writing the code, just as we did with the previous entities, we will explain the purpose of each line so that we can better understand its role in our project. Let's write our code now. We've written the code, so let's move on to the explanations. Public int ID. ID serves as the primary key for the order details entity. It uniquely identifies each record in the database table. Public int order product ID. This field is the foreign key that links to the order product table, indicating which order record, including total amount, the address, customer info, etc., this detail belongs to. Public int product ID. Likewise, product ID is the foreign key referencing the product table. Each row in order details points to the specific product that is part of the order. Public int count. Count indicates how many units of this product are included in the order. If the customer added 3 units of the same product, this field would be 3. Public double price. Price represents the unit price, or the price of the product at the time of ordering. Foreign key, order product ID. Public order product. These lines specify that the order product property is linked to the order product table via order product ID. This means we can retrieve the order's general information, total cost, address, etc. for this detail entry. Foreign key, product ID. Public product. Here, the product property is linked to the product table via product ID. This makes it clear which product is referenced and allows us to access the product's information, such as name, description, etc., in the code. In the next step, you can explore how order product and order details work together or add additional features as needed. That's all for now. Best of luck with your project. In this video, we will examine the coding for the order product entity. In previous videos, we covered most of the attributes and the logic behind properties, so I plan to keep the explanations a bit shorter this time. Let's write our code now. We've written our code, so let's move on to the explanations. We have already explained similar fields in previous videos, such as ID and properties of type string. The primary key, ID, typically represents a unique value in the table, and string fields are used to store textual information. Therefore, we won't go into those details again. Let's just summarize the new or notable fields. Public datetime order date stores the date and possibly time when the order was created. This lets you manage the timing of the order, including day or month or year or hour per minute details. Public double order price represents the total amount of the order. Public string order status indicates the current status of the order, for example pending, shipped, cancelled, etc. Public application user app user, together with a foreign key, app user ID specifies which user in the application user entity placed this order. This establishes a link between the order and the associated user. The remaining fields, cell phone, address, postal code, and name, are also string types that store contact and delivery details for the order. Yes, that concludes what we have to say about the product entity. See you in the next video. In this video, we will once again examine the coding for the product entity. As before, I plan to keep the explanations brief. Let's write our code now. We've written our code, so let's move on to the explanations. In previous entities, we provided general explanations for fields like ID, the primary key, and any string properties. As a reminder, ID identifies a unique record in the table, and string properties store text-based data. Since we covered these topics thoroughly in earlier videos, we won't repeat them here. Let's focus on the notable fields. Public string. Picture can hold the image path or URL for the product. The question mark indicates this field is nullable. Foreign key, category ID. Public category. These two lines specify that the category property is linked to the category table via category ID. As a result, Entity Framework can establish a relationship between product and category. That concludes what we have to say about the product entity. See you in the next video. In this video, we will examine the coding for the product image entity as well. After writing the code, we'll explain the properties. Let's write our code now. We've written the code, so let's move on to the explanations. We have already covered ID in detail in previous entities, where it serves as the primary key. Let's briefly discuss the other fields. Public string image URL stores the URL or path of an image related to the product. This could be a local server path or a link from an external source. Public int product ID indicates the foreign key associated with the product entity, linking this image to a specific product. Foreign key, product ID, and validate never. Foreign key, product ID indicates that the product property is tied to the product table via product ID. Validate never ensures that this field is exempt from model validation. For instance, any invalid data linked to this relationship may be skipped during validation. Public product provides access to the full product object referenced by a product ID. Hence, when you retrieve a product image record, you can easily check which product it belongs to. That concludes our discussion about the product image entity. See you in the next video. Hi. In this video, we will examine how to make modifications and configurations on the application DB context class. When we review the fundamentals of the code, we can see that this class is a DB context derived from Identity DB context. This allows us to utilize the ASP.NET Core identity infrastructure, thus tables for users, roles, sessions, and other identity management functions are automatically created and associated. Within the class, particularly in the constructor, we use the DB context options parameter to pass on configuration settings, such as which database entity framework core should connect to, which provider to use, and other related settings to the base class. In short, this options structure plays a critical role in ensuring entity framework core receives the correct connection and configuration settings necessary for our project to run. At this stage, the basic form of the code is sufficient solely for managing identity authentication tables. However, if we plan to use additional entities, such as product, category, order, etc., later on, we will define them as DB set properties here. Furthermore, by overriding the onModelCreating method, we gain the opportunity to apply custom configurations for both the identity tables and our own entities. With this method, we can detail primary key definitions, table names, relationships, and other configurations. If we are using Onion architecture or a similar layered structure, the application DB context typically resides in the infrastructure layer. This ensures that the domain layer remains abstracted from database details and only accesses this layer via interfaces or model contracts. In summary, while the current version of this class is sufficient for managing identity operations, we can enrich it over time with additional entities and custom rules. As the project grows, the application DB context will become the central hub for all database interactions. In this video, we have reviewed the basic structure of the class. In the next video, we will continue shaping the project by adding DB set definitions and configurations. Hi. In this video, we will examine the DB set definitions within the application DB context class. These definitions ensure that each entity used in our project is created as a table in the database. Each DB set serves as a collection that enables Entity Framework Core to track, query, and save changes for the corresponding entity. Let's write our code now. We've written the code, so let's move on to the explanations. Now, let's explain each of these lines in detail. Public DB set of application user, named application users. This line creates a table for storing records of the application user entity. It manages the table that holds user information in the application. Public DB set of cart, named carts. This DB set represents the cart entity, which contains the shopping cart details for users. Each cart record corresponds to an entry in this table. Public DB set of category, named categories. The category entity is used to store information about product categories. With this definition, it becomes possible to determine and manage which category each product belongs to. Public DB set of order details, named order details. The order details entity stores detailed information about products within an order, such as quantity and price details. Public DB set of order product, named order products. The order product entity contains general order information, for example order date, total amount, user details, and serves as the primary table for order data. Public DB set of product, named products. The product entity holds the basic information about products, name, description, barcode, price, etc. This definition ensures that product data is stored in the database. Public DB set of product image, named product images. The product image entity is used to store image or visual information related to products. Additional images for each product are managed through this table. In summary, these DB set definitions are the key elements that enable our application DB context class to interact with the database. As we have already explained the functions of similar fields, such as primary keys like ID and string properties, in previous videos, we will not repeat those details here. With these definitions, Entity Framework Core will automatically create the appropriate tables for each entity, manage the relationships, and simplify data access operations. In this video, we have reviewed how to set up DB set definitions and their role in the database structure. In the next video, we will continue by adding further database configurations and relationships. In this video, we will examine the coding of the onModel creating method within the application DB context class. As in previous videos, after writing the code, we will explain each line so that you can better understand its role in our project. Let's write our code now. We've written our code, so let's move on to the explanations. First, let's go through the structure of the onModel creating method. Protected override void onModel creating model builder builder. This method allows us to define model configurations in Entity Framework Core. By default, Entity Framework Core creates models in relational databases based on its built-in conventions. However, if we need custom table configurations, relationships, or key definitions, we override this method to implement our own rules. Base.on model creating builder. This line calls the onModelCreating method from the IdentityDB context class, ensuring that the default configurations for identity authentication tables, such as users, roles, sessions, etc., are maintained. If we omit this line, identity-related tables will not be generated and the authentication system will not function properly. Now, let's go over the primary key definitions for the identity tables. And here, we define a composite primary key for the identity as a login entity, which manages authentication providers. Here, the login provider and the unique provider key are set as a combined primary key. What does this mean? Users can log in not only with an email and password, but also through third-party providers like Google and Facebook. Each provider assigns a unique identifier to the user. If the user logs in with both Google and Facebook, there will be two separate login records for that user, each linked to a different provider. This configuration ensures that each login record is uniquely identified based on the provider and its associated unique key. And here, we define a composite primary key for the identity user role entity, which manages user role relationships. The user ID and role ID fields are used together as a composite primary key. Why are these two fields combined? Because a user can have multiple roles. For example, a user may be assigned both the admin and editor roles. A user cannot be assigned the same role more than once. To enforce this, user ID and role ID are combined to create a unique primary key. This configuration ensures that user role relationships are managed correctly and prevents duplicate role assignments. We define ID as the primary key for the identity as a claim entity, which stores additional user-related authentication data. What is a claim and why is it necessary? Claims allow us to store additional details about a user, similar to roles. For example, if we want to track whether a user is a VIP user, their date of birth, address, or special permissions, we can store these as claims. This configuration ensures that each claim record is uniquely identified and associated with a user. In summary, the onModelCreating method allows us to extend Entity Framework Core's default database configurations while defining custom key and relationship settings for authentication tables. In the Identity User Login table, the login provider and provider key are combined as a primary key. In the Identity User Role table, the user and role identifiers are combined into a unique primary key. In the Identity User Claim table, each claim is uniquely identified using an ID column. These configurations ensure that the authentication system operates reliably and consistently. Entity Framework Core manages the relationships in the database according to these definitions and preserves data integrity. That concludes our discussion of the onModelCreating method configurations for identity entities. See you in the next video. Hello. In this video, we will perform migration operations together. Before starting the migration process, let's first explain what migration is and why it is used. If you ask what migration is a mechanism that allows managing and updating the database schema through code using Entity Framework Core. Migrations use the code-first approach, enabling us to create and update the database without manually writing SQL queries. Thanks to the migration process, changes made in C# classes are automatically applied to the database. Thus, instead of writing SQL queries directly to update the database, Entity Framework Core manages these changes through migration files. So, why is migration used? First, to prevent inconsistencies between the database and the code. As entities change within the code, the database schema also needs to be synchronized. Migration automates this process, preventing schema drift issues. Another reason is to make database management more practical. Instead of manually writing SQL queries, Entity Framework Core detects the added or removed properties in the classes and automatically generates the corresponding SQL commands. Additionally, it greatly facilitates teamwork. If team members are working with different databases, migrations can be shared in the version control system and thus, everyone can use the same database structure. Finally, it helps prevent data loss. Writing manual SQL commands can sometimes lead to data loss risks. However, migrations can warn against such changes. For example, if a column is deleted, Entity Framework notifies that this action may cause data loss. How does the migration process work? Migration can be created using Package Manager Console or .NET CLI. To use Package Manager Console, first, go to the Tools menu. Then, click on NuGet Package Manager. Finally, open Package Manager Console. If Package Manager Console is not visible, you can follow the steps above to open it. By default, when we run the .NET F migrations add initial command, the migration should work. However, in some cases, especially when using different layered architectures like onion architecture, this command may not work directly. Before proceeding, let's go to the web layer and open the appsettings.json file. Inside appsettings.json, a connection string is not normally present. However, since we added the identity system as individual accounts, the connection string has been automatically generated. When we check the program.cs file, we can see a configuration that indicates the database connection details will be retrieved using the default connection name. Since this structure is already set up, there are a few areas that we might need to modify. First, we need to check the server connection. If you are using a different SQL server, you need to update this setting accordingly. By default, Visual Studio comes with local DB. If you have a separate SQL server installed, you should adjust the section based on your setup. Next, we should update the database name. Instead of the long default name, you can change it to a custom name that you prefer. For example, let's shorten it to AskNet eCommerce Web. To create a migration, simply enter the following command. .NET F migrations add, then specify a name and press enter. Here, after assigning this name, we need to select eCommerce Infrastructure as the default project, which contains application DB context. Now, when I run and confirm this command, I encounter the following error. No project was found. Change the current working directory or use the project option. What happens if I try to run it in the web layer? When I run the same command in the web layer, I get the same error again. What should we do in this case? Since we are using onion architecture, instead of running the migration command directly, we need to specify which project the migration should be created for and which project should be used as the startup project. For this reason, in Onion architecture, simply running .NET F migrations add initial may not be successful. Additionally, the name initial used here is entirely optional. You can name the migration as you wish. Now, let's examine how to write the correct migration command. How to create a migration correctly. If we are using Onion architecture, we should write the migration command as follows. .NET F migrations add, then specify name, space, -- project, and add the path to the infrastructure layer. After that, leave a space, write -- startup project, and add the path to the web layer. Here are the key points to consider. The infrastructure layer path specifies the infrastructure layer where the migration will be created. The startup project path indicates that the web project will be executed. So, how do we get these paths? First, to get the infrastructure layer path, we follow these steps. Right-click on the infrastructure project. Click on Open Folder in File Explorer. Copy the full path of the infrastructure.csproj file. The easiest way to do this is to hold down the Shift key, right-click on the file, and select Copy as path. We do the same for the web layer. Right-click on the web project. Click on Open Folder in File Explorer. Copy the full path of the web.csproj file. Then, by adding these paths to the migration command, you can create the migration. For example, .NET F migrations add, specify name, space, -- project, paste the full path of the infrastructure layer, space, -- startup project, and paste the full path of the web layer. You can remove the double quotes from the directory paths. When you paste and run this command in Package Manager console, the migration will be created. Once the process is complete, the Build Succeeded message will appear. Right after the Build Succeeded notification, you will see the message. Done. To undo this action, use F migrations removed. For example, let's say I mistakenly gave an incorrect name. I intended to name it initial, but made an error in the naming. In this case, we need to remove the migration using the following command. .NET F migrations remove. However, after running this command, I see that it results in an error. So, what should we do here? We proceed with the same logic and enter. .NET F migrations remove, space, -- project, add the infrastructure layer path, space, -- startup project, add the web layer path and press enter. Once this process is completed, you can create a new migration with the correct name. Conclusion. In this video, we covered: what is migration? Why is it used? How is migration performed? How can migration be removed? In the next video, we will check our database, perform an update operation, and verify whether the tables have been successfully created. See you in the next video. Take care. Hello. In this video, we will explore how to update our database using Entity Framework. After completing the migration process, the changes must be reflected in the database. This is where the Entity Framework database update command comes into play. This command executes the migration files we have created in sequence, updates the database schema, and ensures the required tables, columns, and relationships are created. So, how do we perform this process? Let's go through it step by step. First, we need to run the command from either the terminal or the Package Manager console. We enter the following command. We start by typing .NET F database update. Then, we specify the project layer where the update will be applied. For this, we use the project parameter and provide the full path of the infrastructure layer's project file before executing the command. At this stage, we encounter an error message on the screen. Unable to create a DB context. An error occurred while attempting to activate Application DB context at runtime. Now, you might think that this error is related to the default project selection. To test this possibility, we set e-commerce infrastructure as the default project and run the update command again. However, we still get the same error. So, why does this error occur, and how can we resolve it? When we initially executed the database update command, we only specified the infrastructure layer. However, we did not define the web layer, which is the startup project of our application. To resolve this issue, we need to explicitly specify the startup project as well. So, we modify our command as follows. We first enter .NET F database update. Then, we specify the project to be updated using the project parameter and add the infrastructure layer path. After that, we include the startup project parameter and provide the web layer's path before executing the command. After running the corrective command, receive the message build started, followed by build succeeded, confirming that the process was successfully completed. Did the changes reflect in the database? Let's check. Now, let's connect to the database and verify whether the changes have actually been applied. First, we need to check which database we are connected to. In this project, we are using MS SQL Local DB. According to our app settings.json file, a database named AskNet eCommerce Web should have been created. Now, we open SQL Server Management Studio and connect to the local DB server. Once the connection is established, we know the gate to the Databases section on the left panel, where we can see the AskNet eCommerce Web database. Next, we open this database and examine the tables. When we check the tables, we see that the following tables have been successfully created. Product, Category, Order Details, Order Products, product image, product. Additionally, there are some tables that we did not explicitly create, but Entity Framework automatically generated. AskNet users, AskNet user tokens, AskNet roles. Now, why were these tables created? These tables were generated because of our application user model, which inherits from the identity user class. However, there is something interesting here. We do not see a table named application users in the database. But why? Even though we defined DB set of application user, named application users in our DB context, why was this table not created? Why was the application users table not created? If we examine the application user class, we can see that it inherits from the identity user class. Because of this inheritance, Entity Framework does not create a separate application users table. Instead, it creates the AskNet users table and adds all properties from application user into this table. To confirm this, let's inspect the AskNet users table and its columns. Here, we can see the standard fields generated by the identity user class, such as username, email, normalized email. However, when we scroll down to the last columns, we can also see the custom fields we added in application user: full name, address, postal code, cell phone. This confirms that although an application users table was not created, all of its properties have been added to the AskNet users table. Now, how can we inspect the relationships between tables? If we want to visualize these relationships, we can use the database diagram feature in SQL Server Management Studio. When we analyze the relationships between tables, we can see the products table is linked to category. The part table is linked to AskNet users. The order product table is connected to AskNet users. The AskNet user roles and AskNet roles tables store user role mappings. To view these relationships visually, we can go to the database diagrams section and create a new diagram. To summarize, we executed the .NET F database update command to apply the latest migration changes to the database. Since application user inherits from identity user, no separate application users table was created. Instead, its properties were added to AskNet users. We connected to our SQL Server Management Studio, checked our database, and confirmed that the tables were successfully created. We examined the relationships and verified that foreign key connections were correctly established. Finally, after successfully completing the update process, we should see a message like build succeeded or operation successful. If an error occurs, double-check that all parameters are entered correctly and that the migration process has been fully completed. In this video, we covered database update operations using Entity Framework in detail. See you in the next video. In this video, we'll be working on creating interfaces within the domain layer following the principles of onion architecture. Previously, we discussed what we are going to do and the purpose of these interfaces. Now, it's time to put that theory into practice. Let's dive in and see how we can correctly create each interface file step by step. And don't worry, I'll guide you through the whole process without making it boring. Creating the interfaces folder. First, let's create our interfaces folder within the domain layer. Right-click on the domain layer go to Add, and then click on New Folder. Name this folder Interfaces. Now, why are we creating this folder? Because our interfaces should reside in the domain layer, which is the core of our application. The domain layer must remain independent of external technologies and should only contain the business logic and contracts. Keeping your interfaces in a dedicated folder makes the project more organized and easier to navigate. Creating interface files. Now, let's start creating our interface files one by one. Make sure to change the access modifier to public for each interface file after creating it. First, we'll start by creating our base interface, which is the repository interface. Right-click on the Interfaces folder. Click on Add, then New Item. Search for interface in the search bar. Name it iRepository. Then, click Add. And here's something very important. After creating the file, don't forget to change internal to public for accessibility. This interface will contain all the basic methods required for database operations. Great! We've successfully created our first interface. Let's move on to the next one. The next interface we'll create is for handling user-related operations. Right-click on the Interfaces folder. Click Add, then New Item. Search for interface. Name it iApplication User Repository. Click Add. Again, make sure to change the access modifier to public. This interface will handle all user-related operations such as listing, updating, and deleting users. Alright, let's keep the momentum going. Now, let's create the interface for managing shopping cart operations. Right-click on the Interfaces folder, go to Add, then New Item. Search for interface. Name it iCart Repository. Click Add. This interface will handle operations related to the shopping cart, such as adding, removing, or viewing items. Moving on to the next interface. The next interface will be for managing categories. Right-click on the Interfaces folder, go to Add, then New Item. Search for interface. Name it iCategory Repository. Click Add. Update the access modifier to public. This interface will manage all category-related functions, like listing categories or adding new ones. Next, let's work on the order-related interfaces. Now, we'll create the interface for handling order details. Right-click on the Interfaces folder, then Add a new item. Search for interface. Name it iOrderDetails Repository. Click Add. Change the access modifier to public. This interface will be responsible for handling order details, such as listing products related to an order. Alright, moving right along. The next interface will handle all operations related to products within orders. Go to Add, then New Item. Name it iOrder Product Repository. Click Add. Set the access modifier to public. This interface will handle all operations related to products within orders. Let's move on to the product repository. Now, let's create the interface for managing products. Right-click on the Interfaces folder. Click Add, then New Item. Name the interface iProduct Repository. Click Add. Update the access modifier to public. This interface will manage all product-related functions, like adding, updating, deleting, and retrieving products. Almost there. Let's create the final piece. The last interface we need to create is for transaction management, which is the unit of work interface. Go to Add, then New Item. Name it our unit of work. Click Add. Make sure the access modifier is set to public. The unit of work interface acts as a central manager for coordinating all repository operations and ensuring transaction management. This interface will help maintain consistency when working with multiple repositories simultaneously. Now, let's quickly review what we have done so far. We've successfully created all of our interface files. Just to recap, we've created a base interface for general repository operations. We've created interfaces for user management, shopping cart management, category management, order details, order products, and product management. We've also created the unit of work interface to manage transactions and coordinate repository operations. Remember, we changed the access modifier of each interface from internal to public to ensure accessibility across layers. If you forget to do this, other layers won't be able to interact with your interfaces. By creating these interfaces, we've laid a strong foundation for our project. In the next step, we'll start implementing functionality and building our application one piece at a time. In this video, we'll be working on creating our most fundamental interface within the domain layer, which is the iRepository interface. As you know, this interface will act as the base repository pattern for all our data operations. Our goal here is to build something independent of any specific data source, allowing us to keep our domain layer clean and technology agnostic. Now, why are we doing this? Well, we want our domain layer to be the purest part of our application, completely free from dependencies on databases from any other external systems. The iRepository interface will only define what operations are needed, but it will never dictate how those operations should be performed. That part will be handled by the infrastructure layer later on. Now let's write the code for our iRepository interface. Now, here's something we need to pay attention to. In the getFirstOrDefault and getAll methods, the expression statement is underlined with a red squiggly line. So, why is this happening? The reason for this warning is that the expression statement is not recognized by default. To use this expression, we need to add the system link expressions library to our file. Think of it this way. The expression statement allows us to define and write queries dynamically in C#. But right now, the project doesn't know about the reference required to use this expression. Let's fix this right away. We go to the top of our file and add the following line. System link expressions. That's it. Now, our project can recognize expression statements. This means we can define queries dynamically and make our interface much more powerful. Let's check our code now. Alright, let's carefully examine this line of code because it's actually the most important line that defines the overall structure and purpose of our iRepository interface. This line of code is where we are declaring a generic interface. But what does that mean? Let me break it down for you. What does generic interface mean? When we say generic interface, we are talking about a structure that can work with different types of entities. It's not limited to a single type. Instead, it's flexible enough to work with any class type we want. Now, let's focus on the T part. What does that mean? T is a placeholder or type parameter. When we use this interface, T will be replaced by the specific type of entity we want to work with. For example, if we want to use this interface for handling products, we'll replace T with product. If we want to use it for managing users, we'll replace T with application user. Why are we making this interface generic? Now, here's the critical point. If we don't make this interface generic, we would have to write a separate repository interface for each entity in our application. Just imagine, we'd need a different repository for product, category, user, and so on. This would not only be a lot of unnecessary work, but also create a lot of repetitive code. But with this generic structure, we can handle all entities with a single interface. It's like having one powerful tool that can be used for multiple purposes. Let's go through each method one by one and see what they are supposed to do. Add method. The first method we have is the add method. Its job is to add a new entity to our data source. Here's how you should think about it. The add method allows us to add a new item to our database. The method's return type is void, meaning it doesn't return anything. It just performs the adding operation. The parameter here is tEntity, which is the item we want to add to the data source. For instance, if we want to save a product to the database, we pass that product to this method. But here's the key part. This interface only defines the operation, not how it's actually performed. That implementation detail is something we'll handle in the infrastructure layer. getFirstOrDefault method. Now, let's look at the getFirstOrDefault method. This method's purpose is to retrieve a single item from the data source based on a specific condition. Here's how you can explain it. The getFirstOrDefault method is designed to find the first item from our data set that matches a given condition. If nothing matches, it simply returns null. It takes two parameters. The first one is expression function t, bool filter. This is where we define our condition. For example, if we want to find a user by their ID, this is where we specify that condition. The second parameter is string include properties equals null. This allows us to include related data if necessary. For instance, if we want to fetch a product along with its category, we can specify that here. The real power of this method comes from the use of expressions. It allows us to customize queries directly from the application layer. The interface just states that this operation exists, but doesn't dictate how it should be performed. GetAll method. Now, moving on to the GetAll method. This method is responsible for retrieving a collection of items from the data source. Here's how it works. The GetAll method is used when we need to fetch multiple items from our database. The return type is IEnumerableT, meaning it gives us a list or collection of items. The first parameter, expression function T, bool filter, is optional. If we provide a condition, the method will only return items that match that condition. If we don't specify a filter, it returns all the items. The second parameter, string_include_properties equals null, allows us to include related data if we want. For example, getting all products along with their categories. This method is especially useful for listing large sets of data or applying specific filters to our queries. Update method. The update method is straightforward. It's designed to update an existing item in our data source. The return type is void, meaning it just performs the update operation. The parameter tEntity represents the item we want to update. The interface is only saying update this item, but doesn't define how it's done. Remove method. Now, let's look at the remove method. This method allows us to delete a specific item from the database. It takes a single tEntity as a parameter and removes it from the data source. Again, the interface doesn't dictate how the deletion is performed, only that it should be possible. Remove range method. Finally, we have the remove range method. This method is designed to delete multiple items at once. For example, if we want to delete all outdated orders or remove products in bulk, this method will be useful. The parameter IEnumerableTEntities represents the collection of items to be deleted. Just like the other methods, it only defines the operation, not how it's executed. Why are we doing this? The purpose of defining this interface is to keep our domain layer clean and independent from any data access technology. By defining only the necessary operations, we are following the dependency inversion principle, ensuring that high-level modules depend on abstractions, not concretions. What's next? Now that we've created our iRepository interface, we've established a strong foundation for handling data access. Next, we'll be creating specific repository interfaces for each entity and implementing them in the infrastructure layer. See you in the next video. Hello. In this video, we will be implementing the code for all of our interfaces. But before we begin, I noticed something missing in the interface that we forgot to create. When reviewing our entities, I realized that we have a product image entity, but we haven't created an interface. Let's quickly create the interface for product image. First, we need to right-click on the Interfaces folder, select Add New Item and choose Interface from the menu. We will name it iProductImage Repository and click Add. Now, we need to change the access modifier from internal to public. Now, let's add the basic code for this interface. So, what are we doing here? We are creating an interface named iProductImage repository, which inherits from the iRepository interface. This means that all the methods defined in iRepository will be available in iProductImage repository. And more importantly, this interface is specifically designed to work with the product image entity. However, there's something to watch out for. We can see that product image is underlined with a red squiggly line. This happens because the project doesn't recognize the product image entity. To fix this issue, we need to add the proper reference at the top of our file like this: e-commerce, domain, entities. Once we add this line, the error will be resolved. Now, here's something important to note. The reference we just added for the product image entity will also be needed in our other interfaces. So, we need to make sure that every interface file includes the following line: e-commerce, domain, entities. Without this reference, we will encounter errors whenever we try to use our entities. Next, we'll proceed to implement the remaining interfaces. The approach will be the same for each one. We will only create the interfaces and write the basic code for them. I will provide detailed explanations of each interface in the next video. To keep this video short, we'll focus only on completing the code structure.
La nuit caresse ma peau brûlante. Chaque souffle est une douce attente. Les ombres dansent, mes lèvres tremblent. Désir brûlant, tout se désassemble. soir, laisse-toi aller vers le contrôle. Je t'appartiens ce soir. Laisse-toi aller vers le contrôle. Je t'appartiens ce soir. Laisse-toi aller vers le contrôle. Embrasse-moi, touche-moi, serre-moi fort. Laisse le temps s'effacer dehors. Corps vacant, sueur brûlante. Dans cette nuit, plus rien n'attend. Je t'appartiens ce soir. Laisse-toi aller vers le contrôle. Je t'appartiens ce soir. Laisse-toi aller vers le contrôle.
We have successfully implemented all of our interfaces. In the next video, I will explain what each interface does, how it works, and how it's structured. That's all for now. See you in the next video. Hello there. In this video, we're going to dive into the detailed explanations of the interfaces we previously defined in our domain layer. Our code is already written, and now we'll go through each interface to understand what they do and how they work. Let's get started. First, let's talk about the iProduct repository interface. This interface directly inherits from the iRepository product interface. So what does that mean? It means all the basic data operations related to the product entity, such as add, update, remove and get all, are already handled by the base iRepository interface. That's why we didn't need to define any additional methods specifically for iProduct repository. And this structure also applies to all our other standard entities. For example, interfaces like iCategory repository, iCart repository, iOrderDetails repository, and iApplicationUser repository are all derived in the same way from the iRepository T interface. Thanks to this structure, we've centralized all the shared CRUD operations in one place, avoiding code duplication across entities. Now let's move on to the iOrderProduct repository interface. This one also inherits from iRepository OrderProduct, so it brings in all the base methods. However, here we've also defined an additional method. Here, we have a method called updateStatus, and it's used to update the status of an order. It takes 3 parameters. The first one is ID. This tells us which order we're going to update. The second is order status. This is the new status we want to assign to the order, like processing or delivered. And the third one is payment status, which is optional. That means we can leave it empty if we don't need to change the payment info. But if we do want to update the payment status as well, we can simply pass a value for it. Why did we add this? Because when it comes to order-related operations, updating the order status and payment status is a very common need. With this method, we can update both the order status and optionally the payment status in a single operation. This makes our data access layer more flexible and allows us to perform domain-specific updates directly without relying on additional service layers. And now let's take a look at the iUnit of Work interface. This interface acts as a central hub that brings together all of our repository interfaces in one place. Here you'll see App User, Cart, Category, Order Details, Order Product, Product, all defined as properties within this interface. And we also have a save method defined here. This method is used to commit all the changes made through the repositories in a single transaction. The biggest benefit of this approach is that it ensures all operations are saved together, and if anything goes wrong, the whole process can be rolled back. This is a key principle of transaction management. You'll also notice that the iUnit of Work interface implements iDisposable. This means that when we're done using the object, we can release its resources by calling the dispose method. This is particularly useful in large-scale applications to keep memory usage efficient and under control. Another detail worth mentioning is that all the repository properties in this interface are defined with get only. So, why only get and not set? Well, by defining these properties as read-only, we ensure that repository instances can only be accessed, but not reassigned from the outside. This is a solid principle for maintaining control and consistency in your application's architecture. In other words, any service or class that uses the unit of work structure can access the repositories, but they can't inject or assign a new iCart repository instance from the outside. By doing this, we produce and manage all repository instances from a single point and only expose their references externally. This ensures that the control over our repository instances always remains centralized. It also improves the readability and maintainability of the code. It's a neat and secure approach overall. So in short, the get keyword here allows external access to the repositories, while the absence of set prevents them from being modified externally. This small but important detail helps solidify how our iUnit of Work interface works. Alright, in this video, we've explored the technical details and responsibilities of our interfaces. In the next video, we'll move on to writing the concrete implementations of these interfaces. See you there and take care. Hello. In this video, we're moving on to another important part of our project. We'll create the repositories folder under our infrastructure layer and then define the repository classes inside it. As you know, in the previous step, we defined our interfaces within the domain layer. Now, it's time to write their concrete implementations. So, let's go ahead and walk through the steps one by one. Let's create the repositories folder. To begin, we right-click on the infrastructure layer, select Add, and then choose New Folder. We name this new folder Repositories. Why did we create this folder? Because grouping all of our interface implementations in one place increases the readability and maintainability of our project. Also, since this layer is where our actual data access happens, placing all repository classes here perfectly aligns with our architecture. Let's add each repository class. Now, we'll create a repository class for each entity, one by one. And don't forget, Make sure to change the access modifier of each class to public so it's accessible from other layers. First up, the base repository class. We start by creating our foundational class, the repository class. Right-click the repositories folder, choose Add and select Class. We name this file Repository. This class will be designed to be generic, meaning it can work with any entity type. It will implement our base interface, iRepository. This is where we'll write all the basic data operations like add, delete, update, and list. Think of this class as the backbone. All other repository classes will inherit from it going forward. Next, the repository for application users. We now create the application user repository class. This class will inherit from the base repository and work specifically with the application user entity. It will also implement the iApplication user repository interface. And as always, don't forget to make it public. Then, the repository for cart operations. Now we move on to the cart repository. Same steps, create a new class, name it cart repository. It will inherit from the base repository and work with the cart entity while implementing the iCart repository interface. After that, the repository for category management. This one is called Category Repository. It will also inherit from our base repository and connect to the category entity through the iCategory repository interface. Moving on, repository for order details. We repeat the same process and name this one Order Details repository. This class will handle all operations related to the order details entity. Now, the order product repository with a twist. This one is a bit special. We create a new class called Order Product Repository. It still inherits from our base repository and works with the order product entity. But here's the difference. This repository also includes a custom method called update status. This method is designed to update both the order status and optionally the payment status at the same time. Since these kinds of updates are common for order products, we've added a method that specifically handles this use case. This way, we're making the repository more flexible and better suited to the needs of this entity. Continuing with the product repository. Next up is the product repository. Just like the others, it will inherit from our base repository and work with the product entity using the iProduct repository interface. Then, the product image repository. We now add the product image repository. Same idea, it will inherit from the base repository, work with the product image entity, and handle all data access related to product images. And finally, the unit of work class. Now let's talk about one of the key players in our architecture, the unit of work class. This class serves as a single access point for all the repository interfaces in our project. It implements the iUnit of work interface. Inside, there's a method called save, which commits all data changes at once. This is extremely useful for keeping your data consistent. There's also a dispose method which helps clean up resources and manage memory efficiently, especially important in large applications. Final thoughts. And that's it. In this video, we created the repositories folder inside our infrastructure layer, defined repository classes for each entity, and built a solid, clean structure for our data access layer. Now we have a strong foundation to move forward. In the next video, we'll start adding actual code to these classes and walk through the logic step by step. Hello there. In this video, we're going to write the core structure of our repository class and explain in detail what this structure does and why it's important. So, what exactly is the repository pattern and why do we use it? A repository is a pattern that abstracts data access, meaning it allows us to interact with data through a consistent interface rather than accessing the database directly. Even though we use an ORM like Entity Framework, instead of dealing directly with the DB context, we go through the repository, which makes our code more flexible, more testable, and easier to read. Especially in layered architectures like Onion architecture, the repository pattern plays a crucial role in isolating data access logic from the domain layer and reducing dependencies. Alright, now let's get started and write this structure together. We begin by writing public class repository of T. Here, T is a generic type definition. This means our repository class can work with any entity type. Then we add the constraint where T is a class, which ensures that T must be a reference type. In other words, we can't use value types like int here, but instead use class-based entities like product, category, etc. Next, our repository class implements the iRepository of T interface, which means we commit to providing implementations for all methods defined in that interface. Inside the class, we define two fields. The first one is underscore context, which is of type application DB context. We're going to pass this from the outside via the constructor. In simple terms, when this class is instantiated, it will receive our Entity Framework database context, so it knows how to connect to the database. The second field is an internal DB set of T named _DB set. This represents the database table associated with the entity type we're working with. So, for example, if we create a repository of product, this _DB set will point directly to the products table in the database. Now let's look at the constructor of the class. We write public repository, and it takes an application DB context as a parameter. Inside, we assign the incoming context to our _context field. Then we initialize _DB set by calling context, set of T. This dynamically gives us the correct DB set based on the entity type. Lastly, we write our first method, which is called add. This method takes an entity of type T and calls _DB set, add entity, to queue it for addition to the database. Of course, keep in mind that this only prepares the data for insertion. The actual save operation, where the changes are written to the database, will be triggered later using the save changes method, which we'll manage through the unit of work structure. Great! We've completed our coding for this section and explained in detail what each part of the code does. In the upcoming videos, we'll take a closer look at the other methods inside the repository class, like getAll, getFirstOrDefault, update, remove, and so on. Each method will be covered in its own video, where we'll both write the code and walk through it step by step to understand why we build it that way. See you in the next video. Hello. In this video, we're going to write the getAll method inside our repository class and explain it in detail. As you remember from the previous video, we had already created the skeleton of our class and set up the basic structure. Now it's time to start writing functional methods step by step. This particular method will be one of the most commonly used ones in the repository pattern. Why? Because we'll use it to list records from the database, apply filters, and optionally include related data through navigation properties. Let's begin writing the code now. We've written our code, so let's now walk through what it does and how it works in detail. So here, we're defining a method called getAll. The word public means this method can be accessed from outside of the class. It returns an IEnumerable of type T, which basically means it gives us back a list of data, whatever type T stands for. Since T is a generic type, this method works with any entity we pass in. This method takes two parameters. Expression-typed filter parameter. This allows us to apply a custom filter during listing. For example, if we want to retrieve only the items where the ID is 1, we can pass that filter here. String include properties equals null. This optional parameter lets us include navigation properties. So if we want to load related entities like a products category, we'll use this string to tell the method which ones to include. iQueryable T query equals underscore dbSet. Here, we initialize our query using underscore dbSet. At this point, no filter is applied yet. This just sets up the base of our query to work with the database set that represents the table. If filter is not null, this block checks if a filter was passed in. If it is not null, we apply the where method to the query using that filter. This allows us to, say, only get active records or any other condition dynamically. This part handles the inclusion of related entities. If include properties is not null, we split the string by commas and use the include method on each one. This is useful for eager loading, where we want to fetch related data in the same query. For example, when retrieving an order, we might also want to bring in the related products. Return query to list. And finally, we execute our query and return the result as a list by calling to list. This method now returns the final list of filtered and included records back to the caller. To summarize, this method supports filtering. It includes related tables if needed, and returns the final data as a list. Thanks to this structure, we now have a flexible, extensible, and readable data access method. So that's it for this video. We wrote our getAll method and walked through every detail. In the next video, we'll move on to our other methods like getFirstOrDefault, add, update, remove, and more. See you in the next one. Hello there. In this video, we'll take a slightly different approach and show how we can automatically implement the methods inside our repository class. We'll also walk through how to properly write the getFirstOrDefault method using this method. Let's first take a moment to recall. Previously, we declared our class like this: public class repository of T, and we mentioned that it implements the iRepository interface. Now, here's something interesting. You might notice that the iRepository part is underlined in red. Why is that? Well, that's because the methods declared inside the iRepository interface haven't yet been written inside this class. So we told C# that we'd follow the contracts defined in the interface, but we haven't fulfilled that promise yet. Here's where Visual Studio makes life easier for us. If we hover over the red underlined iRepository, we'll see a little light bulb icon. When we click it and choose Implement Interface, Visual Studio will automatically generate all the method signatures from the interface for us, ready to be filled in. Super handy. As you can see, methods like getFirstOrDefault are now all here, just empty shells for now. So what's next? Now we'll fill in the content of these methods ourselves. Let's start with getFirstOrDefault. And here's the fun part. We can actually reuse the code from the getAll method. So, let's go to the getAll method, select all of its code and copy it. Then we paste it into the getFirstOrDefault method. there are just a couple of small changes to make. First of all, the return type of getAll is IEnumerable, which gives us a list of data. But getFirstOrDefault is supposed to return only the first item. So here, we'll keep the return type as just T. At the bottom of the method, instead of calling .toList, we'll call .FirstOrDefault. Because we're only interested in the first match. Also, just like in getAll, we're using the query variable. And this is where iQueryable comes into play again. You might be wondering, why don't we just write _dbset.firstOrDefault directly, instead of setting up this whole query object? Well, it's because we also want to support both filtering and loading related data using include properties. That's why we use iQueryable. It allows LINQ queries to be built up piece by piece and then executed efficiently on the database. With this approach, the filter is applied first, then any related tables are included, and finally, FirstOrDefault executes the query. This method is also great for performance. Only the necessary data is pulled from the database. And there we go. We've completed our getFirstOrDefault method and walked through the reasoning behind each part. In the next video, we'll continue exploring the rest of our methods. Hello! In this video, we're going to implement the methods that we previously left with the not implemented exception placeholder. We're focusing on 3 different methods. Let's begin by writing the code for each of these methods. Then, we'll go through what each one does in detail. Here's the code we've just added. Alright, now that the code is written, let's break it down and talk about what it all means. The first method is remove. This is used to delete a single record from the database. It takes in a parameter called entity and passes it to the remove function on the _db set, which marks it for deletion. Now, just to remind you, we had already initialized _db set in the constructor earlier on. So what happens here is that Entity Framework begins tracking this entity for removal. The actual deletion from the database will only occur once we call the save method later. Moving on to the remove range method. It does something similar, but instead of dealing with one item, it works with multiple records at once. It accepts a list or collection of entities, and then we use _dbset.removeRange to mark all of them for deletion in one go. And now for the update method. This one's used when you've made a change to an entity and want those changes to be saved into the database. We're essentially telling Entity Framework, this data has changed, please keep track of it and update accordingly. Keep in mind though, just calling update doesn't immediately write changes to the database. It simply flags the changes internally. For the changes to take effect, the save method needs to be called afterwards. And there you have it. In this video, we've implemented and explained the remove range, and update methods. See you in the next video. In this video, we'll make our previously created application user repository class fully functional. As always, we'll first write the code, and then go through it line by line to explain what we did. Let's write our code. Okay, now that we've finished coding, let's go through it step by step. Let's look at the first line. In this line, we're actually doing three things at once. We're defining a class, inheriting from a base class, and implementing an interface. The repository of application user part. Here, we're using the generic repository class we created earlier. That class was designed to work with any entity type. Now we're passing in the application user entity as the generic parameter, which means this repository will now work specifically with the application user table. This allows us to reuse all the core methods like add, remove, update, getAll, and getFirstOrDefault, without having to rewrite them. Since all of that logic already exists in our base repository class, we avoid code duplication and improve the maintainability of our project. The iApplicationUserRepository part. In this part, we're implementing the interface for the class. If you recall, in the domain layer we defined an interface for each entity. Here, we're implementing the iApplicationUserRepository interface. But why do we do this? Because we want other parts of the application to refer to this class through its interface, not through the concrete implementation. That way, even if we change the internal logic of this class in the future, other parts of the system won't be affected. In other words, this approach helps us abstract dependencies and make our code base more flexible. Now, let's look at the constructor. Here, we're defining a field to hold the database context provided by Entity Framework. This is the object that enables communication with the database. We assign this context to our private_DB field. And we also pass it to the base class using the base keyword. This allows the base repository to perform core operations like add and remove using the same context. And if we ever need to write a method specific to application user in this class, we can access the database directly via _DB. In summary, this class is a repository specifically created for the application user table. We inherit from repository application user to avoid rewriting common logic. We implement the iApplicationUserRepository interface to enforce abstraction and reduce coupling between application layers. We receive an application DB context instance from outside and configure it so that both this class and the base class can access it. That's it. In this video, we've fully configured our application user repository class. We've explained the inheritance from the base class and the interface implementation in detail. In the next video, we'll explore how to use this structure with practical examples. See you in the next video. Hello and welcome. In this video, we're going to define the order product repository class and explain how it's structured. Let's begin by writing the code together. Great, the code is now written. Let's move on to the explanation. As you can see, this class inherits from our base repository, that is, repository of order product, and implements the iOrderProduct repository interface. Now, Since we've already gone into full detail about inheritance and interface implementation in our previous videos, particularly when we covered the application user repository, we'll keep this part brief here. The takeaway is, by inheriting from the base repository, we avoid writing basic CRUD operations again. And by implementing the interface, we ensure consistency across our architecture. So, what's new in this class? You'll notice we've added a method called updateStatus. Its full signature reads: public void updateStatus takes an integer for ID, a string for order status, and optionally, a string for payment status. But right now, you might be thinking, the method is defined, but there's no code inside. Exactly, and that's by design. This method is a placeholder, a planned slot for a feature we'll likely need later. We're anticipating that we'll eventually add payment status tracking to our orders. And when that happens, this method will let us update both the order status and payment status in a single operation. For now, we've used what's called a not implemented exception, which is like saying, this functionality isn't ready yet, but we've reserved the spot for it. This is a common and smart practice, especially in scalable software design. It helps keep your code clean, extendable, and well prepared for future changes. To summarize, the class is properly structured with inheritance and interface implementation. The updateStatus method has been added to accommodate future business needs. And for now, it throws a not implemented exception until we're ready to build out its logic. Clapperboard, that's all for this video. In the next one, we'll continue expanding our repository classes and exploring how they fit into our overall architecture. Thanks for following along, and see you in the next video. Hello and welcome. In this video, we'll be creating the repository classes for the remaining entities in our project. We'll write the code for the repositories of category, cart, order details, product image, and product entities, and we'll structure them using exactly the same logic we used when building the application user repository and order product repository classes, which we've already explained in detail in earlier videos. So, in this video, we'll skip the explanations and focus only on writing the code. Alright, let's go ahead and write our code. Great, we've completed the coding part. And just like that, we now have all of our standard repository classes in place. Each one inherits from our base repository class and implements its corresponding interface. Since their structure follows a repeating pattern, we didn't add any new explanations in this video, but feel free to check back on our previous videos if you'd like a refresher on how the base logic works. Now, it's time to move on to one of the most essential components in our architecture, the unit of work repository. In the next video, we'll write the code for that class and walk through each part of it step by step. See you in the next video. Hello. In this video, we're going to configure one of the most important building blocks of our project, the unit of work class. Let's start with a quick note on naming. Earlier, when we were creating our repository classes, you may have noticed that we named this file unit of work repository. Now, that wasn't a mistake. In fact, it was done intentionally so we could explain why that name isn't the best fit for this class. Let's go ahead and correct the name. We rename the file to unit of work. When we do that, a message box appears in the center of the screen, asking if we'd like to update all references to this class as well. Do you want to also rename all references to this class? And yes, we approve the suggestion. The IDE will now automatically update the class name everywhere it's used. So, why should we call it unit of work instead of unit of work repository? Because this class doesn't interact directly with the database like a typical repository. Instead, it manages and coordinates multiple repositories under a single structure, like a central manager. And more importantly, this is a well-known pattern in software architecture called the unit of work pattern. So this isn't just a naming choice, it's a concept. The class isn't a repository itself, it's a unit that combines and manages many repositories. That's why the correct and conventional name is simply unit of work. Now that we've updated the name properly, let's go ahead and write the unit of work code. We now begin writing the code. Alright, the coding part is now complete. Let's walk through what we've written and explain it step by step. So first, at the top of the class, we define a private field. Application DB context underscore DB. This will hold the reference to our database context, the bridge that lets us talk to the database. Then we have the constructor. Public unit of work takes application DB context as a parameter. Here, we assign the incoming context to our private field so we can use it throughout this class. Now let's talk about each of the repository properties one by one. We've defined read-only properties like app user, cart, category, order details, order product, product. Each of these returns a new instance of the corresponding repository class, and we pass in the same context to each one. This ensures all repositories are connected to the same database context instance, which is crucial for consistency and transactional integrity. Now you might notice something important here. All these properties only have a getAccessor. So, why don't we have set? We define only get because we don't want other classes to replace these repository instances from outside. The whole point of unit of work is to act as a central access point, and we want full control over how and when those repository instances are created. This gives us better encapsulation, more predictable dependency handling, and overall cleaner architecture. Now, let's look at the final two methods. Dispose. This method is used to release resources and close the connection to the database when we're done. It's part of proper memory management, especially important in larger scale applications. Save. This is one of the most critical methods in the unit of work. It commits all the changes made through the repositories to the database in one go. So instead of calling save changes on each individual repository, we now call save once, and all changes are applied together. This approach gives us transactional consistency, meaning either everything is saved successfully, or nothing is saved at all, which prevents partial updates or corrupted data. So to wrap it all up, the unit of work class acts as a central hub for coordinating repositories. It ensures consistent context usage across the app. It handles saving and disposing resources in a clean and unified way. And it prepares our architecture for scalability, maintainability, and testability. This is a key step in building clean enterprise-level applications. In the next video, we'll take a look at how to inject this unit of work structure into the application layer and how to start using it in practice. See you in the next one. In this video, we're moving into the web layer of our project and working inside the program.cs file to configure one of the most essential parts of our application, dependency injection. If you remember from our previous lessons, we've already set up our domain and infrastructure layers, created our repository classes, and defined our unit of work structure. Now it's time to make these components available throughout the application by registering them into the service collection, which is accessed via Builder, Services. First, inside our program.cs file, we locate the following line. var builder equals web application.createBuilderArgs. This line sets up the application's initial configuration. Right below it, we're going to start registering our services. So let's go ahead and add these service registrations. Builder.services.add scope type of iRepository generic, comma type of repository generic. Builder.services.add scoped angle a unit of work close angle. Let's break it down. In the first line, we're registering the generic interface iRepository and mapping it to its implementation repository. This means whenever the system needs something like iRepository product, it will automatically provide repository product. We're using add scoped because we want a new instance of the repository to be created for every HTTP request, which is the most appropriate life cycle for web applications. In the second line, we register our unit of work and map it to the unit of work class. So anytime the application requests our unit of work, the system will inject the corresponding implementation. This setup allows us to manage all repository operations centrally using a unified structure. Now you might have noticed a small but important difference in syntax. In the first line, we used typeof, but in the second, we didn't. Why is that? The first registration is for a generic type. iRepository accepts type parameters like product or category, so we must declare it using typeof, iRepository. The second one is a non-generic interface. Our unit of work is a specific, concrete interface, so we can register it directly without using typeof. To sum it up, if you're working with generic services, you need to use typeof. If the service is non-generic, a direct reference is just fine. This difference is entirely based on whether or not the interface supports type parameters. In summary, we've registered our repository and unit of work services. We're using scoped lifetimes to ensure each request gets its own instance. And we've implemented this using ASP.NET Core's built-in and powerful DI system. This step is absolutely critical for keeping our architecture clean, scalable, and testable. Alright, in this video, we've successfully introduced our iRepository and our unit of work structures into the system via dependency injection. In the next video, we'll see how to make use of this setup within the application layer. See you in the next one. Hello. In this video, we're going to start creating our viewModel classes inside the application layer. Before moving on to our service layer, we first need to prepare some viewModels, especially for use cases where we need to work with multiple models at the same time. First, we'll create a viewModel called CartVM. For this, we'll add our CartVM class inside the viewModels folder that we previously created within the application layer. Let's write the code. Now that the code is written, let's walk through what it does. The first line defines a property named orderProduct. This will be used to hold the summary of the current order. The second line defines a list called listCart. This list will store all cart items related to the user. We're using IEnumerable of cart to keep it flexible for listing operations. In other words, this viewModel allows us to carry both the order summary and the list of cart items within a single structure, especially useful on pages like checkout or order confirmation. To summarize, a viewModel is used to group and transfer multiple entities together. CartVM combines both orderProduct and listCart into a single model that can be passed to the view. This keeps our application layer clean, organized, and easier to maintain. Alright, in this video, we've created our first viewModel, CartVM, which will be used in views where we need both order and cart information at the same time. In the next video, we'll continue building our other viewModels. See you there. Hello. In this video, we'll be creating the final ViewModel class for our application layer. The name of this class is Product VM. For product-related operations, we'll need to handle both a product object and a list of categories for drop-down selection. That's exactly where our Product VM class comes in. Let's jump right into it. Inside the ViewModels folder we created earlier in the application layer, we add a new class named Product VM. Let's write the code for this class. Now that we've written the code, let's walk through the details. The first property is product. This will be used to display and send product-related information through a form. Things like name, price, barcode, and description will all be part of this object. The second property is category list. This will be used to populate a drop-down menu so that users can select a category when creating or editing a product. We're using selectListItem, which is a standard ASP.NET MVC structure for rendering drop-downs. And here's something important. We've added the validateNever attribute just above the category list property. Because this property doesn't come from the user, it's populated by the system. So, we don't need to validate it as part of the form submission, and that's exactly why we're using validateNever. To summarize, the Product VM class wraps both a product object and a list of selectable categories. This allows the UI to show product info alongside a drop-down of available categories. The validateNever attribute ensures we don't try to validate data that's system-generated and not submitted by the user. Alright. In this video, we've created the final view model in our application, Product VM. We also took time to explain its structure and purpose. All of our view models are now complete. In the next part of the series, we'll begin working on our services. See you there. Hello and welcome. In this video, we're moving forward within the e-commerce application layer of our project. Actually, we already stepped into this layer earlier when we created our ViewModel classes. Now, we're going to structure the service layer, which will handle the core application logic. Before jumping into actual coding, let's set up our folders and files step by step. First, we create a new folder named Services under the application layer. This folder will contain the service classes that handle business logic. These services will act as a bridge between the repository layer and the controllers. They will process data, prepare it, and make it ready to be consumed by the outside world. Next, to make our services more modular and organized, we create a subfolder inside services called Admin Services. Why a separate folder? Because as the project grows, will likely have different service sections, such as customer services, public services, etc. Keeping each group in its own folder helps improve maintainability and readability of the project. Now let's move into the Admin Services folder. Inside this folder, we'll be adding service classes that will handle operations related to the admin panel. In this lesson, we'll be creating a total of 4 different service classes. Category Service will manage all category-related operations. Order Service will handle order processing and status management. Product Service will manage product-related logic and business rules. User Service will cover user management operations. For each of these classes, don't forget to set the access modifier to public, because they'll be accessed from other layers as well. We'll handle the actual coding and implementation logic in upcoming lessons. To summarize, we created a services folder inside the application layer. Then we added a subfolder named Admin Services. Inside it, we added 4 service classes: Category Service, Order Service, Product Service, and User Service. This structure forms the backbone of our service layer. From here on, our business logic will be organized and processed through these services. Alright, in this video, we laid the groundwork for our service architecture by creating the necessary folders and class files. In the next video, we'll start coding the logic inside these services step by step. See you there. Hello. In this video, we'll add our first methods to the previously empty category service class and explain each step. Let's start by writing the code. Great, the code is in place. Now, what did we do here? Private read-only IUnitOfWork_UOW. We declare a field named _UOW to hold our unit of work instance. The read-only modifier ensures it can only be set in the constructor, preventing reassignment elsewhere. Constructor, public category service, IUnitOfWork UOW. This constructor receives an IUnitOfWork instance named UOW via dependency injection. Inside, we assign that instance to our underscore UOW field. GetAllCategories method. We call underscore UOW category.getAll to retrieve all category records from the repository. The result is returned as an IEnumerable category. Any controller or consumer can now call this method to get the full list of categories. To summarize, we introduced the underscore UOW field and injected it via the constructor. We implemented getAllCategories to read from the category repository. With these steps, Category Service now has its basic data retrieval functionality. In the next video, we'll add and explain the create, update, and delete methods in the same way. See you in the next one. Hello. Now, let's add and explain the create category, get category by ID, and update category methods in our category service class. First, let's write the code. Great, the code is in place. Now, let's walk through what each method does. First, create category. Takes a category object as a parameter. Calls underscore UOW category, add category to add the new category. Calls underscore UOW save to persist the change to the database. In essence, this method safely adds the provided category into the database. Next, get category by ID. Uses the ID parameter to specify which category to fetch. Calls underscore UOW category.getFirstOrDefault x.id equals ID to retrieve the first matching record. Returns the found category object. This allows controllers or other services to easily fetch a single category by its ID. Finally, update category. Takes an updated category object as a parameter. Calls underscore UOW category, update category to mark the record for update. Calls underscore UOW save to commit the changes to the database. This method ensures any modifications to the category are saved permanently. To summarize, create category adds a new category. Get category by ID fetches a specific category by ID. Update category updates an existing category. With these three methods, our category service now covers the create, read, and update steps of basic CRUD. In the next video, we'll implement and explain delete category and error handling. See you there. Hello again. In this video, we'll implement the delete category method in our category service class. Let's start by writing the code. Great, that's our method. Now let's break down what each part does. First, we attempt to find the category by calling underscore UOW.category.getFirstOrDefault with a lambda x arrow x dot ID equals ID. This returns the matching category object or null if none is found. Next, we check if category is null. If it is, we immediately return false to indicate that no deletion occurred. Then, if a category was found, we call _uow.category.remove passing the category object. Right after, we call _uow.save to persist our changes to the database. Finally, we return true to signal that the deletion was successful. To summarize, we locate the category by ID. If not found, return false. Otherwise, remove it and save, then return true. With delete category in place, our category service now supports full CRUD operations. In the next video, we'll add similar methods to our other services. See you there.